We don't often have Dr. Sungenis here in Southern California, so I'm going to save as much time as possible for you to have with him. I want to address what I think will be the first pillar to fall. The title of the talk tonight is The Coming Scientific Revolution. I don't think I'm telling anybody in this room anything they don't already know. The pillars of our civilization are shaking. Not only the financial pillars, moral pillars, cultural pillars. Good heavens, 45% of the inhabitants of this country want to redefine what marriage means. We're entering a time when certainties are collapsing. What a lot of people don't understand is that one of the foundational certainties, some would say the foundational assumption of the modern world itself, is also wobbling. Our film is called The Principle because it deals with that foundational principle of the modern world. It's the Copernican principle. And the Copernican principle is really something very simple. When you really look down at it, what it says is that we're nothing special. All of modern science is predicated on the notion that we, here on Earth, we are not in a special location. There is nothing special about our location. There is nothing special about where we are, who we are, what we are. That the laws of physics are going to be the same everywhere in the universe. There are going to be no special locations, no special directions. This is the foundational principle of modern science. It begins, strangely enough, with a pope. In the 16th century, the calendar was getting a little sketchy. We didn't have the leap year. And the Pope was asking the smartest men in Europe to help him, just like the church always did at that point. The smartest guys in the world would help the Pope do important things like make sure the calendar worked, so we knew when to plant things and when to celebrate Easter. At that time, it was funny. It was the exact opposite of what we have today. Back then, science was just to save the appearances. In other words, just to make sure that everything could be worked out right, you know. They weren't trying to tell you anything about the nature of reality. That was for theology and philosophy and metaphysics. Science was just to make the appearances fit, right? This guy Copernicus came up with a way that he could explain some of the weird anomalies that had bothered people about the geocentric system. For example, if you watch Mars over a period of months, you're going to see something really interesting. It appears to change directions in the sky. Anybody who's an amateur astronomer who's ever watched this happen should do it sometime. It's fascinating. Okay. You watch Mars, it goes this direction, then it changes, and it goes this direction, and it changes, and they couldn't figure out why that was. Didn't make sense. Well, Copernicus, in the context of trying to find a way to respond to the Pope's call for an improvement of the calendar, hit upon this idea. Wow, if I let the Earth move, I can explain what's going on because Earth's moving and it's passing Mars, right? And so when it passes Mars, it seems like Mars is going backward, and then Mars will catch up on the other side of the orbit, and everyone went, wow, what a fantastic notion, what a fantastic idea. We interviewed perhaps the world's leading expert on the revolution between the Ptolemaic and the Copernican system for our film, Dr. Julian Barber. He's on the cover of Discover magazine this month, actually, so good guy, he gave us a great interview. And he said that the Copernican revolution had nothing to do with the sun at the center of the universe, had nothing to do with it. If you look at the original map that Copernicus drew for his book, the sun does not appear in that. It was not a heliocentric system. It was just a system that allowed the Earth to move so that they could explain this paradoxical motion of Mars. But that was the beginning. That was the beginning because science at that point began to say, this isn't just a way to make the calendar work better. this is the way things really are. That's the most crucial moment in the whole history of science, right there. It's where modern science begins. Because from that moment forward, science was no longer just about making the appearances fit. Science was about telling us what was actually true, what was the underlying reality. Up until that moment, that had been the basis of metaphysics and theology. There is your Copernican revolution. The Copernican revolution marks the overturning of what had up until then been the hierarchy of knowledge. The hierarchy of knowledge used to be theology, the queen of sciences, because after all, the only certain knowledge comes from God. That's what the world believed. If it comes from God, you can darn well put your faith in it. It doesn't matter if it comes from men. You can never put 100% certainty in it. Beneath that, metaphysics, the study of being as being. And then beneath that, philosophy. And science was just a branch of philosophy. Science was just natural philosophy. So in the hierarchy of knowledge, science was much lower than theology. The reason that the Galileo affair became such a huge deal for the church was because the popes were smart enough to realize that this inversion represented an overturning of the entire Christian worldview. It really did. And if you don't believe me, Dr. Sungenis covers it in his book very carefully. Make no mistake about it, folks. The popes, the magisterium, and the church considered Galileo's system to be a direct attack on the unanimous consensus of the fathers concerning the interpretation of Scripture. And they considered it to be a matter of grave import for the Catholic faith. Now let's fast forward 300 years. 300 years ago, Christendom reigned throughout the European world. There was no question that the average man in the street believed that the Scriptures were the inerrant and inspired Word of God, that the Church had received from heaven a mandate to teach infallibly those matters pertaining to our salvation. Everyone believed that. The Church saw Galileo come up and said, this represents a mortal threat to Christian civilization. 300 years later, everything has changed. Theology is now down here somewhere. Theology doesn't teach us the reality about things. It's just about, understanding spirituality and stuff. Right? It's science that we put our stock in. By golly, if science says it, we can flick the light switch and it by my cell phone. Watch this. You want to see? I predict that this is going to light up. Whoa! That's where I want to put my faith. Right? That's our civilization today. It's a complete inversion. Now it's science that tells us the way things really are. The reason that I believe that Dr. Sungenis has written the most important book, the most important book written by a Catholic in the last 50 years, is because his thesis is that the real moment where things change for the church, the real moment where Christendom begins its decline, and the modern post-Christian world begins its ascent, is the Galileo affair. Because that was the first time in history that the average man in the street was made to believe that the Scriptures could be wrong, and the church could be wrong in telling us how to interpret them. That marks the change, the signal change in the direction of our civilization. Now, I could go on about this, but I want to give Dr. Sungenis as much time as possible tonight. So I want to jump forward. After Copernicus, along came Kepler, and Kepler was, heliocentrism really doesn't begin with Copernicus, it begins with Kepler. Because Kepler worked very closely with a great geocentrist named Tycho Brahe. And Tycho Brahe had observed the planets for 30 years and had come up with a geocentric system that answered the very same anomalies, the retrograde motions of Mars. He had come up with a system that preserved Earth at the center and explained every single one of those motions. And he wanted Kepler to help him develop it. Kepler, on the other hand, wanted Brahe's 30 years of observations so he could improve the heliocentric system, sort of like a Mexican standoff. Well, nobody knows exactly what happened except that Brahe died and Kepler got the notes. How that happened, there are many opinions. It would make an interesting story, actually. But what we know is that Brahe died. And Kepler got the notes. And Kepler used those notes to write another incredibly influential book, which put not only did it put the sun at the center, but it gave us an incredible idea that the sun was somehow responsible for moving the planets. This was a radical idea. And then it fell to Isaac Newton to take that notion and develop it into the greatest single scientific discovery in history. And this is a geocentrist saying this now. I am telling you as a geocentrist that the single most brilliant scientific idea in history was Isaac Newton saying, oh, it's gravity. It's gravity. That's the beginning, really, of our modern science. And of course, gravity depends upon the idea that that big, big sun, of course the small, small Earth has to go around the big, big sun. Everybody can understand that. How could anybody possibly, anybody with half a brain, how could anybody doubt that for a second? Well, actually, there's a number of very good reasons to doubt that. First and foremost among which was, all of the fathers unanimously had interpreted Scripture as teaching the opposite. Now, back in those days, folks, that was a big deal. The faith was very strong in those days. And people back in those days had a hard time with the notion that some theory from some brilliant scientist ought to be allowed to overturn the unanimous consensus of the fathers on Scripture. So Galileo, absolutely convinced, for very good reason. I mean, after all, the theory of gravity is very persuasive, folks. I got news for you. You ask 1,000 people in this city tonight, do you believe in God? Probably 500, 600 will say yes. You ask 1,000 people, do you believe in gravity? 1,000 of them are going to say yes. It's the new religion. It's the new faith. Here's where it gets interesting. When Galileo walked into the Inquisition and laid before them his proofs, Saint Robert Bellarmine, the wise Cardinal Bellarmine, took one look at those proofs and snorted in derision and said, "This is absurd." Galileo tried to say that the tides, the motion of the tides, proved that the Earth was going around the sun. We now know that to be false. Every scientist on Earth knows that every argument Galileo brought to the Inquisition has been scientifically falsified. I'd just like to repeat that. So that if you remember nothing else that you hear tonight, please remember this. Every single argument Galileo raised before the Inquisition has been conclusively falsified. Now, why don't you hear that? Good question. Because you see, the church condemned two propositions of Galileo. Number one, Galileo said that the sun was motionless at the center of the universe. Well, even the heliocentrists know that's wrong now. Score, Inquisition 1, Galileo nothing. And there's no controversy on that. There are no heliocentrists anymore, in the historical sense of the word. Nobody believes that the sun is motionless at the center of the universe. The second proposition that was condemned, this is the big one. This is the big one. The Inquisition condemned as heresy the notion that the Earth is rotating on its axis and orbiting the sun. It's condemned as heresy. Now, be honest with me, folks. Please don't be embarrassed. Honest. How many people in here believe that it has been, please be honest with me now. How many people believe that it has been scientifically demonstrated? When I say scientifically demonstrated, I mean something very specific. I mean experimentally demonstrated. It has been measured and can be repeatedly measured. If I want to see it, you can show it to me. How many people believe that it has been experimentally demonstrated that the Earth rotates on its axis once every 24 hours and revolves around the sun once every 365 days? Who believes that's been proven?
I'll bite.
Okay, very good. Would you be kind enough to share with us what experiment it was that demonstrated for us that the Earth is rotating on its axis once every 24 hours and revolving around the sun once every 365 days?
I'll admit that my degree is in political science. But it seems to me that, recalling the few physics classes I took back in college, I thought that pretty much the 3 Newtonian laws that we use to pretty much get a satellite from here to there.
Excellent. Very good answer. Very good answer. Thank you. The answer is an excellent answer. Indeed, there is no experiment that proves it. But if it's wrong, why can we get satellites to go where they're supposed? How come we can get to the moon? How can you tell me that this is wrong? Thank you very much. Now you see why the church in the end had to shut up. Because it was so convincing. Newton's gravitational laws were so profoundly successful that in the end, even the cardinals and the Pope were convinced that they had to shut up about Galileo. If only they would have held on another 40 years. In your physics studies, did you hear of something called the theory of relativity?
Yes.
Okay. Did they explain to you why we had to toss Newton overboard?
Yes.
Why?
Newton was never able to explain exactly how gravity worked. He could only pretty much describe it. Plus, the 3 Newtonian laws actually do have a few errors. Mercury's orbit, I know, has a slight inclination, which doesn't seem...
All of this is very good. I'm sorry to cut you off, but actually, that's not right. That's not why Newton was tossed.
Okay.
Okay, go ahead.
Because Maxwell's equations prove that nothing can move faster than the speed of light.
Okay, you're getting closer. Maxwell's equations were in fact very problematic because Maxwell's equations were based on the existence of something called the ether. Now we're going to get to what actually caused Newton to be tossed. Everything was working beautifully. As a matter of fact, Max Planck, the discoverer of quantum physics, was advised not to go into physics by someone that he wrote a letter seeking an admission to, because he was told that we'd figured everything out. There was nothing left to figure out. He should go get into something else because physics was done. This was in the last couple of decades of the 19th century. We figured it all out. It's over. There's nothing big left to discover. Well, God has a wonderful sense of humor, and pride does come before a fall. You know, everything worked beautifully. Yeah, there was problems with Mercury's perihelion, but those were minor details. Here was the real problem. We all knew. It had been established for hundreds of years. Everyone with half a brain knew that the Earth was going around the sun. This was not a controversial issue. Only one problem. They'd never been able to experimentally measure the motion. No experiment in all history, beginning with Dominic Arago, all the way through. They had Fresnel, Fizeau, George Bedell, Airy's failure. These men expected to be able to measure this motion. We knew how fast it was going. Had to be going about 30 kilometers a second, right? All of physics, Maxwell's equations included, were based on the knowledge of an ether. What is ether? Well, ether is the substance of space. Well, why does space have to have a substance? Well, because we know that light's a wave. What's waving? Right? You can't go surfing without an ocean. You can't have a light wave without some medium to transmit it. All of physics, up until 1905, was based. You couldn't get a degree in physics in 1905 if you didn't believe in the ether. Keep that in mind the next time somebody tries to convince you that science has things figured out. 100 years ago, you were crazy if you didn't believe in the ether. You couldn't explain electromagnetism without the ether. Well, there was one problem. If the ether existed, we should be able to directly measure this motion of the Earth around the sun. Why? Well, because the light waves are being propagated through this medium, and if the Earth is plowing through this ether at 30 kilometers per second, I got an idea. We'll build this big instrument. We'll have an arm that goes this way, and we'll have an arm that goes this way. And we know how fast light goes, right? We'll shoot a beam up this way, and we'll shoot a beam up that way. We'll split the beams and combine them, and we'll be able to measure by the interference when we recombine them how much the Earth has moved in the time it took for the light to go those two directions. Simple. The problem is, when this experiment was done, first in 1881, and then again in 1887, by Michelson and Morley. The experiment was done in Cleveland, Case Reserve University, to the absolute astonishment of every physicist on Earth. The result was, the Earth was clearly not plowing through the ether at 30 kilometers per second. Now, there was some question about just how much motion was being shown. The standard answer you're going to get today was that there was a no result. There was a no result. That's false. Just as a matter of history, I want to tell you, if they tell you that it was a no result, they're lying. That's not true. The experimenters themselves wrote up their experiment and reported it in the American Journal of Physics?
Yes.
Yes. You can read it in Bob's book, the page is reproduced. They reported a result. The result was not no. The result was simply far too little to account for a 30-kilometer motion of the Earth around the sun. But it was reported as no. Why? Well, here's where that very smart fellow, sitting in the patent clerk office in Zurich, Switzerland, named Albert Einstein, enters the picture. Here's where the modern world begins. Physics, they were beside themselves. They had no explanation. All of the standard explanations for phenomena like stellar aberration were based on the idea of the ether. The Michelson-Morley experiment gave them two and only two choices. Number one, well, the Earth isn't going around the sun after all. Let's all go to Rome and start a novena to St. Robert Bellarmine. No. That was never on the agenda. So that was tossed. But if you read the historical works, the biographers are honest enough to point out that that was always one of the explanations that would have been consistent with the evidence. The evidence would have been consistent with the fact that, well, the Earth's not going around the sun. But that was dismissed not on scientific, but on physics, philosophical grounds. In other words, we know gravity works. We know the sun's over there. Everything works so well. Of course that can't be it. So it was tossed. Wasn't even considered. What does that leave us with? Well, then obviously the ether is moving along with the earth, right? Well, that doesn't work either. That doesn't work either. Because you see, even if the ether is being dragged along with the earth, there still should be some interference because the earth has moved a certain amount during that time. But they weren't measuring that fringe shift. Leave it to Einstein to come up with the answer. And he got it from one of the guys who was trying to explain it through the ether. Lorenz said, okay, here's what's going on. Here's the answer, folks. Ready? We know the Earth's moving, and in the direction that the Earth is moving, the measuring rod on our device is shrinking. Yes, that's right. It's shrinking, and what's really interesting is that it's shrinking just exactly enough to make it look like the Earth's standing still. Isn't that remarkable? What a coincidence. That the ether is shrinking the rod just enough to make it look like the Earth is standing still. You will still find this referred to as the Lorentz contraction. Did you study the Lorentz contraction? Okay. Isn't that fascinating, though, that it was shrinking just enough? What a coincidence, huh? Well, not even modern science was prepared to swallow that one. It was literally laughed out of court. There was no physical reason why it should be shrinking. There was no even proposed reason why the ether should shrink a metal rod. And why just exactly that much? Einstein came up with a much better idea. Nobody's going to believe the rod is shrinking, right? So Einstein said, well, wait a minute. It's not the rod that's shrinking. What's shrinking?
Space.
No. Time. Time is shrinking. When you see our movie, you'll see that we show the Michelson-Morley experiment. And we show that there was a little fringe shift there, right? And you see that the rod shrinks and the fringe shift goes away. All fine, it shrank. No, we're moving, right? All Einstein did, this is all special relativity is. It's exactly the same equation, exactly the same numbers. It's just that L for length in Lorenz's equation becomes T for time in Einstein's equation. Time shrinks. Time moves at different rates, depending on the state of motion of the body. Welcome to the modern world. Now I'm going to finish up real quickly here, because this story just begins here. But I will tell you that the entire world changed on that day. All of a sudden, rods begin shrinking, time begins moving at different rates, and there are no absolutes left in all the universe. Nothing is still. Nothing is constant. Everything is relative. Why? Because the only other alternative was to admit that the Earth wasn't moving. As hard as it was to swallow the idea of rods shrinking and clocks moving at different rates, it was a heck of a lot easier to swallow that than the idea that the church had been right all along. I'll leave you with two very interesting observations. All of modern physics is based, keep this in mind, the theory of relativity exists because of the failure for 3 centuries of science to experimentally prove the motion of the Earth around the sun. That was the one nail they couldn't hammer down. Everything else, beautiful. Number 2, when we accepted relativity, we had to accept certain things that come along with it. And this is why we are in a crisis of cosmology that Bob will share some more with you. If we believe relativity, we believe that there are no preferred locations, there are no preferred directions. There can be no particular direction we look in the universe that allows us to define a preferred location. It is absolutely impossible under the theory of relativity for us to be able to look at the universe on its largest scales and say, that's north, that's south, that's east, that's west. Everything has to be more or less the same in whatever direction. That is the Copernican principle extended to the whole universe. Not only are we nothing special, not only are we not in a special location, there are no special locations, no special directions, no special locations. This is where they're in deep, deep trouble. In 2001, and I'm skipping over many things you can read in Dr. Sungenis' book. I'm just going to the one that's really going to blow the lid off of this. In 2001, a device was launched to measure the cosmic microwave background. You guys have heard of that? COBE? Yeah. Well, no, this was WMAP, the one after COBE. COBE was launched in 94? 1990. What they saw with COBE freaked them out so much that they spent a whole bunch of money to build something called the Wilkinson Microwave Anisotropy Probe, the WMAP for short. You see, under Big Bang theory, everything has to be the same. It has to be isotropic. In other words, it has to look the same in any direction, right? But that's not enough. You see, things could look the same in every direction, even if you were in a special place. Think of a desert, right? Let's say you're on top of a big rock in the desert. Well, you can look 360 right. Everything's going to look the same to you, right? But if you walk off of that rock and do a 360, the rock's going to look different, right? So that rock would be a special place. Can't have that. The universe has to be isotropic, has to look the same no matter where you look, and it has to be homogeneous. It has to look the same no matter where you're looking from. Can't be any rock, it just has to be desert, right? They put up WMAP in 2001 to look at what had tantalizingly sort of troubled them from the COBE, which is that the predicted uniformity of this microwave background, which is alleged to be the oldest light in the universe. In the Big Bang cosmology, after the Big Bang, there's a period of about 300,000 years where there is nothing but energy. And then there is a moment of decoupling where the photons decouple and we begin to have transparency in the universe. Structures begin to form. We start with helium and hydrogen, and then 13.7 billion years later, here we all are, right? Another wonderful coincidence, right? Time and chance. The problem is, COBE found that cosmic microwave background wasn't perfectly isotropic and homogeneous. This was interesting. So they put up the WMAP in 2001, and that is where things started to get very interesting. We interviewed for our film Professor Max Tegmark of Massachusetts Institute of Technology. He describes for us in our film the night he became the first living human being to observe something called the axis of evil. You've heard of the axis of evil? Haven't heard of the axis of evil? Second thing you don't want to forget when you go home tonight is to Google WMAP axis of evil. Now, what they discovered was that in these tiny fluctuations of the cosmic microwave background, they found astonishingly that there were universe-wide planes between the warmer and colder sections. These were aligned with one another. When Max talks about discovering this, he literally says, I hit my computer and it gave me the picture and I went, whoa, that's crazy. It wasn't supposed to look like that. It's supposed to look random, remember? Everything's all the same in every direction, no special direction. Well, guess what? There are giant universe-spanning alignments in the oldest light in the universe. These define an axis. That axis is pointing, and I'm sure this is just a coincidence. That axis happens to be directly aligned with the ecliptic and the equinox of completely insignificant, purely random, and unimportant Earth. This is so shocking. This is absolutely impossible to reconcile with Big Bang cosmology. That's why it has been called the axis of evil. Why evil? Because it's bad news for the theory of relativity. That's why it's evil. You've got to take my word for it. The idea that the largest structure that we can see in the universe is defining a universe-spanning arrow that's pointing directly at the equinoxes of Earth, the point where the sun crosses the equator every year, and at the plane of the ecliptic, which is the plane that the planets orbit the sun. Remember, they say the Earth is tilted at 23.5 degrees on its axis? Okay? Well, that tilt is precisely the plane that we describe as the ecliptic. If you were to take the Earth and put it back up, so it was straight up and down, then the planets and the sun would be inclined at a 23.5 degree angle. Now, I'll leave you with this. Tycho Brahe, remember that guy who wound up dead all of a sudden, and Kepler had all of his notes, right? Remember him? He had devised a system that answered every single one of the observations in the sky, the retrograde of Mars, all the retrogrades, the phases of Venus, all of these things were answered. Ptolemy's system had Earth at the center and everything else going around Earth. Brahe said, no, Earth is at the center, but the Earth only has two satellites. It has the sun and it has the moon. Everything else in our solar system is orbiting the sun, right? And the sun and the planets are orbiting on this ecliptic plane. And everybody said, why in the heck should that be? Why should everything in the whole solar system be orbiting at an angle like that? What's so special about that angle? And you know what Brahe said? He said, I don't know. Got no idea. But I do know the Bible tells me that's what's happening. And then he died. Okay? 300 years later. One. And precisely one cosmology. Only one predicts a cosmological significance to that 23.5 degree angle. Only one cosmology predicts that 23.5 degree angle is of much greater than merely local significance here for our little system. Because Tycho Brahe predicted that the sun and the stars and the entire rotation of the universe was related to that 23.5 degree angle. And in 2004, 350, 400 years later, we put up a satellite. We finally get to see the whole extent of the visible universe. We'll never see any further out, because light can't get to us from any further out. When you look at the largest structure in the universe, that 23.5 degree angle is built in to the entire cosmos. I could go on, but I want Dr. Sungenis to have time to address this. We stand on the verge of a massive revolution in cosmology. I want every one of you to not be intimidated at all. There is a crisis in cosmology. There's a crisis in evolution. Right? Now, don't get me wrong. The church allows great freedom and latitude in these areas, and I'm not anybody's bishop. But I will say this, it's a great time to believe the church had it right all along. And that 100 years from now, our apologists will be trying to come up with explanations for why we didn't say so.